Moments of inertia, type 4 rolling discs pulleys. C, rotating pulley and 2 particles. So in 2008, we were given a rotating pulley and 2 particles. And again, pulleys and wedges is where we normally see these questions. So it's unusual to kind of see this come up in moments of inertia. But again, it's a lovely little question to come up, a bit like when we were looking at our B. So here we have 2 masses, 4 and 6 kilograms, suspended from a light, inextensible string. So it's not going to be bouncing around. And it's passing over a pulley. We're told the axis of rotation of the pulley is horizontal, perpendicular to the pulley, and passes through the centre of the pulley. So we have the moment of inertia of the pulley is actually given to us this time, so we don't need to work that out. And we're told that the radius is 20 centimetres. Now, of course, if the radius is 20 centimetres, we're going to need to change that into metres, because we can see here the moment of inertia is given in terms of metres squared. We're told the particles are released from rest and move vertically, and when each mass has acquired a speed of 1 metres per second, we have to find 1, the common acceleration, and 2, the tensions. Now, normally when we're looking at our pulleys and wedges, we have common acceleration and common tension because it's just one string. But here we're looking at the tensions in just the vertical portions of the string. So in other words, the mass themselves, how are they affecting just the string in the vertical portion? So rather than saying common tension for this question, we're going to give the tensions 2 different letters. So T1 and T2, or T and S, as I will use, okay? So obviously 6 kilograms is going to have a larger mass, so therefore we would imagine that it's going to accelerate down, where the 4 kilogram is going to accelerate up. Therefore, gravity acting on our 6 kilogram particle gives us a weight of 6g. So let's say our tension is acting up, away from our particles. So I'm going to say T and S, and as I said, you can call them T1 and T2, whatever you prefer. And of course, then if we look at the pulley itself, well, tension always acts away from the object, so therefore the tension on the pulley is acting away from the pulley itself. And of course the pulley is going to have then angular velocity, while the particles will only have linear velocity. Now, as one is falling down, the other is going to rise. So therefore, if one falls down a distance of h, the other is going to rise by that same distance. Okay, so therefore, because they're moving in opposite directions, one will have a change in potential energy in the opposite direction to the other. So we'll have to apply a negative sign to one. Okay, so the first part of the question is that we have to find the acceleration. So we know to get our acceleration, we need, of course, our our principle of conservation of energy. Okay, so let's have a look at our principle of conservation of energy. So we're going to have our change in potential energy, and we have 2 particles this time, so we'll have 2 potential energies, is equal to the change in kinetic energy. And again, our kinetic energy is going to comprise of the angular velocity of the pulley plus 2 particles which only have linear velocity. And again, our potential energy equations and our kinetic energy equations can be found then on page 54 and 55 of our maths tables. Okay, so as I was saying there a second ago, we're going to have one rising and one falling. So one gaining in potential energy and the other losing in potential energy. So because the 6 kg is going to go down, I'm going to take that as my positive direction, right? So we have 6gh, and therefore if the 4 is moving in the opposite direction, it's going to have minus 4mgh. sorry, I shouldn't be putting in an M there. So I used to not knowing the masses. So we have 4GH, I should say there, sorry. And then we're going to have our moment of inertia. So rather than working it out, we were actually given it this time, and we saw that that was 0.08 kilograms per meter squared. Our angular velocity. Okay, so our angular velocity, if I just go up to the top here, we have V is equal to, or omega, and therefore omega is going to be equal to the velocity. And we're told that it acquires a velocity of 1, and the radius we're told is 20 centimetres, but we need to change that to metres, so that's going to be 0.2, and therefore the angular velocity is 5 radians per second. Okay, so now we have the angular velocity. We can put that into our equation. We have to make sure that we're squaring that. And then we have half times the mass of the 4 kilogram times the linear velocity. Well, it's acquired a speed of 1, plus a half times the mass of the 6 kilograms. And it has also acquired a linear velocity of 1. Okay, so simplifying all of that gives us 2GH on the left, and on the right hand side I end up with 6, and therefore H in terms of G is going to be 3 over G, and therefore if I want to find the acceleration, well, V squared equals U squared plus 2AS. And we know that it starts from rest. It acquires a speed of 1. And it's moving a distance, we've just worked out, of 3 over G. So subbing in gives me 1 squared is equal to U squared, which is just 0, plus 2A times 3 over G. And therefore getting A on its own is G over 6. Okay, so that gives us our common acceleration. So that was the first part of the question, and we had 20 marks going in total for that. So we had 5 for getting our kinetic energy, and 5 for getting our loss in potential energy. So in other words, we had 10 in total for getting out our 2 equations there. So for 5 for the left and 5 for the right. And then we had 5 for getting out our change in height. And then we had 5 for getting out the acceleration. So 20 marks in total there. Okay, so the next part of the question is find the tensions in the vertical portions of the string. So if we're looking for our tensions, we're going to be looking at our F equals MA to look at our net forces. So for the 6 kilogram, if we start with that one, well, it's moving downwards. So let's go back to the diagram. So it's moving down, so the leading force is going to be weight, and the opposing force is the tension in the string, which I've called S, and that's going to equal the mass times the acceleration. So the weight is 6G minus the tension is equal to the mass, which is 6, times the acceleration, which we've just worked out to be G over 6. So of course 6 goes into 6 once, and then that leaves us with S is equal to 5G. And so it doesn't say find the value of, so we can leave our answer in terms of G, or of course if you want to work it out as the value, then that would be 49 newtons. So we had 5 marks for getting the first one out. So the second one then we have there is 4 kg, and it's going up, so therefore the leading force is going to be the tension this time, and the opposing force is the weight. That equals mass times acceleration. So T minus 4G equals 4 times G over 6, and therefore T is equal to 14G over 3, or 45.7 newtons. And again, 5 marks for that. So lovely little 30-mark question there. And again, especially if you like your pulleys and wedges questions, it plays nicely to that.